Hey, what's up, guys? Hey, I just want you guys to know that you guys are totally legit, and I love you. Okay, maybe that's a little too much, but yeah, I hope you guys do awesome on your test. Okay, so that's kind of why I'm here right now. I wanted to go through problem number 5 because that's a really good problem for us to practice. This is from Unit 11 now. It's a really good way for us to practice the whole lattice energy stuff. And if you remember, this question asks us to calculate the second electron affinity of oxygen using the information below. So if you remember in the previous question, which is right over here, we calculated the lattice energy. And so it'll be the same, basic same steps, but this time we're solving for something else. We're solving for the second electron affinity of oxygen, because oxygen is O2 minus, and we have the first electron affinity here, which is minus 141, but we don't have the second electron affinity. So here's a clue: it's going to be a positive number, because the first electron affinities are usually negative, but the second one is usually positive, because once that first electron gets in there, that second one sort of requires a little bit of energy to kind of get in place, because the first electron causes some repulsion. So that's just a clue for you. So anyway, I set up the problem down here. Someone's going to walk us through the steps. The first thing that we want to do, as I told you guys before, is we want to set up our delta H, or formation equation, because that represents our lowest energy state. So I'm starting out with magnesium solid plus O2 gas, and gives me MgO. So okay, as you guys notice, this is a mistake. This should actually be MgO, not MgO2. And since I want the heat of delta H, or formation, it should be 1/2 O2. Because remember, for delta H, or formations, I want to form 1 mole of the product. And so I have to balance it on both sides. So I have magnesium, 1 magnesium, and to get 1 oxygen, 1 mole of just oxygen atoms, single oxygen atoms, to multiply O2 by 1/2, and I'll get 1 mole of oxygen atoms over here. So that's balance, and we're good, and that's our delta H, or formation equation. So then at the top, we're going to write our highest energy states. So like I said, delta H, or formation equation, represents our lowest energy state. And we're going to be moving, when we add energy to the system, we're moving up this energy chain. So at the highest peak, we have Mg2 plus as a gas, and we have O2 minus as a gas. And so those are the highest energy states of magnesium and oxygen that we're going to work with in this question. And that jump from Mg2 plus gas and plus O plus oxygen 2 minus gas, from there in that high energy state down to this solid lattice state, that's what we call our lattice energy. And so that's actually given in the problem. And so we don't have to worry about solving for that, but we can use that to find our second electron affinity. So let's walk through the steps. So the first thing we want to do is take magnesium from a solid to a gas. So in order to do that, we have to put energy into the system. And so if you guys look at the book here, that's the delta H of deposition. So it's a negative 148, and that's going from, deposition is going from a gas to a solid. But we want to go from a solid to a gas, so we have to reverse that sign. So we do that, and that's 148. And then we do our first ionization energy, and then our second ionization energy. So when we add those in, and those are given here as well, that's 738 and 1450. When we add those in, then we get, we add all those together, we get 2,336 kilojoules per mole, and now we have our Mg2 plus gas. So the next one is oxygen, and that's kind of a little bit more tricky, and the reason is because O2 naturally comes as diatomic oxygen, but we only want 1/2 of that. So the first thing we have to do is break it into single oxygen atoms. So we're given the bond energy of O, but we only want 1/2 a mole of O. So we have to multiply this 498 by 1/2, and that gives us 249. So don't forget that step. So we have 1 mole of just oxygen, single oxygen atoms. So the next step we want to do is do our first electron affinity. But remember, I told you guys that the first electron affinity is negative. So we actually, and it's right over here, first electron affinity, it's actually a negative number. And so we're actually going to go down in energy, because we're releasing energy from the system once we add that that first electron in. And so that's given, like I said, by negative 141. And then we do our second electron affinity. So this 2 shouldn't be here. And so now we have O2 minus gas. And so, and that's our X, that's our unknown. This is what we're trying to solve for. So if we add all that up together, on this side we get 108 plus X, and that's the X we're trying to figure out. And so in total, the sum of our steps from this standard state to this gaseous state is the sum is equal to I think I worked it out. X plus